else used to go out in the field and do research by recording, and used to have to use those big reel-to-reel tapes. Now technology's improved, and so this is what we used after the reel-to-reel tapes. The technology got better, things started to get smaller. So this was a German audio recorder, one of the first digital audio recorders to come out. And everybody's quite excited about that because that allowed you to start to get data in a lot of different places. Plug in different kinds of mics and, easily portable. Since that time, we're down to about this. This is about as small as you can get. Or if you want different directional mics, you can go with something like this. But these are nifty little devices. They run off of AA batteries, amazingly. Or you can plug them into external sources of power. And technology has improved so much, everything is recorded on these now. This is what holds all the recordings these days, these little things instead of the reel-to-reel tapes. So lots of improvements have led to lots of research opportunity. When we go out into the field, this is one of our main pieces of equipment. This is going to collect data 24 hours a day. It actually captures everything that's out there in terms of the recordings. And then we pair it up with a decibel meter so we can tell how loud or how quiet things are. So a lot of this equipment is batteries and or cables, to hook everything together. And really the two pieces of external equipment are a microphone and a weather station. All the sensitive equipment is actually kept in these Pelican cases. And we keep them locked up and we try to protect them as much as we can because they are sensitive. So for example, these sound meters, like the one I brought into class the other day, these are pretty sensitive and they get you down to about the 30 decibel range. The real technical equipment, this decibel meter costs about $200. The ones that you use in the field are about $10,000. And so you want to keep them safe, you want to keep them protected. So that's why we haul all that equipment around and lock everything up. But it helps tremendously now to be able to collect a lot of data. So the dB monitors have become much smaller, the recorders are much smaller, and this piece of equipment is an old Palm Pilot that we developed years ago to make sound logging easier. We used to sit there with a pen and a piece of paper and just write things down with a watch. And what this allows you to do, we can now do it on smartphones too. I hear the wind, okay, I hear people, I hear a vehicle. And you can just tap on these and then tap off them when you stop hearing things. And it gets much more easy to be able to get a lot of sound sources at once, whereas in the past you'd be just focused in on one or two things. I just want to give you an idea of how we can go about doing some research. So you can sit around and listen, you can do some audibility logging, what's out there, right? How often are things audible? You can do some recording. That's what you use these nice little digital recorders for. You can do another approach called attended listening, where you may have some recordings already and you want to see how people respond to them. So you may take a computer, set of headphones, and have a standardized procedure that they are going to listen and rate to in the park. We've done that kind of work before. We can take the recordings that we collect out in the field, bring them back to the lab, and remember when I showed you guys all those nice pictures of the landscapes? You can add sound in and start to do the same type of thing with sound. You can ask people questions, you know, what's their experience like. You can pair a lot of these things together. And now we're at the point where we're starting to take physiological readings, similar to what you've been reading about in Florence Williams' book, in the Nature Fix. The technology has improved so much that we can get brainwave measurements, EEG activity, actually outdoors in the field, because we've got portable equipment. We can hook up your brain while you're hiking, or while you're sitting, or while you're listening, or doing whatever. So this is where we're going these days. Lots of cool stuff with physiology. This is a map of Bryce Canyon National Park. This is the northern part of the park. So to orient you, this is Highway 12 coming in, and then this is the road that goes down to the end of the park. I guess it was about 8 years ago, Bryce called and wanted some data from a variety of different areas in the park to assess how loud people were and how areas were being used or not used, as the case may be. And so what you see here are a number of little circles on the map itself that we thought would be a good place or good places to go and do some attended listening. So you saw the northern part of the park, now the southern part of the park, again with circles in different locations, to get an idea of what the road sounds like, what the viewpoints are like, and then what some of the backcountry areas are like as well. All right, so if you've been to Bryce, you see the area around, the busy area around the lodge. We can start to break down what you actually hear based on percentages. And so in this area, you hear people a lot, you hear vehicles a lot, and then you hear the first natural sound, birds, and the wind are the two most frequent sounds from nature that you hear, at least in the lodge area. And I'll scroll through a few of these slides so you can see the different percentages. But what really struck us when we were up in Bryce was this: jet airplanes. 31% of the time? Really? That was surprising to us. You know, the motors, the cars and stuff like that you'd expect, at least in this location. But just about everywhere in Bryce you hear high altitude jets 25 to 30% of the time. And I'll show you why in a minute. So these are just straight percentages. How often or how audible are these sources? The other metric that you see on here is an NFI. This stands for noise-free interval. And so what that means is if you are in this location at the lodge and you're simply sitting and listening, and if we measure the amount of time where there's no human-caused sound, that's what the noise-free interval is referring to. The longest noise-free interval at the lodge was 43 seconds. The average was 14 seconds. Those are important numbers when you start to do some comparisons with other areas. If you've been to some of the overlooks, Sunrise and Sunset are two of the more popular ones close to the lodge. And again, you can just kind of eyeball some of these numbers and you can see which areas of the park are busy simply based on how often you hear people. 77% of the time you're going to hear people at this viewpoint, speaking and walking. And again, you get the birds and the winds, vehicles, but jet planes are popping up. But now look at the noise-free interval. The longest is 642 seconds. The average is 50 seconds, so the average goes up, but the longest that we found there was a little over 10 minutes, almost 11 minutes long, which is a good chunk of time. Rainbow Point down at the far southern end of the park. So if you drive all the way to the end, you end up at Rainbow. And you see, not as visited as much. You hear people as often, and the noise-free interval is quite a bit longer, the longest one there. But again, jets anywhere from 20 to 30% all throughout the park. Here's why you hear so many planes in our parks. This is a graphic of U.S. passenger jets, high-altitude passenger jets, from takeoff to landing site. So the lines represent one flight. One flight is one line. This is one day in the United States. The estimates are high-altitude passenger jets have increased by 25% since 2000. So add a 25% more lines on there, and that's what today looks like. What's fascinating about a map like this is that you can begin to identify cities just based on the number of flights going in and out. One other graphic on here that I think is important for you to try to find, look at the red. Those are our national parks. This will show you where the quietest areas in the country are simply by looking at a graphic like this. What you can actually see on the map more clearly than the parks are the military bases, because you can't fly over them. So the reason that flights go from San Francisco like this, and then you see the curve, this is military. Nevada test site, Area 51, and fly over. Do. Down here, right on the Mexican border, that's Organ Pipe National Monument. Right around it are bombing ranges, military bombing ranges. The quietest areas in the country are actually military sites when they're not doing exercises. You eliminate all the high altitude planes.